So up till now, the solving that we did was just basic solving, where we had to like say, okay, what can we make with monomials and stuff like that, right? But now we're going to do ones where we can have binomials in the bottom for fun. So we have x squared minus 3x, x minus 3, and x. If you look at all three of them, you'll be like, there's nothing in common with them. There's no way on the diploma that they're going to make you multiply each one of those things by the other two. If that's what you think you need to do, go back and say, hey, maybe there's a GCF or difference of squares in one of the denominators that might make that denominator be like the other ones, so I don't have to multiply by a bajillion numbers, which is just craziness. Okay? So if you look in the bottom left here, I can take out an x. Because our first goal when we're solving or adding and subtracting is to get common denominators, or else we can't. Okay. And then we have 6x minus 3, and then 5 and x. So what I can make each of them be now is a little bit more obvious. I can make them be x and x minus 3, right? If I remember to take that GCF out. The bottom left, on the left-hand side of the equal sign, already is x minus 3. This 6 over x minus 3, Cody, what am I going to have to multiply it by? X. And Parker, what am I going to have to multiply the f or the 5 over x by?
X minus 3.
Yeah. Now, you guys, you don't have to distribute in the denominators. You can leave them just as x and x minus 3. If you distribute them back in, you're going to have to take them back out to state MPVs. So there's no point in doing that, right? But the top, we will always distribute in and collect like terms. But the bottom, you can just leave separate. So here we have 18 over x minus 3 equals 6x over x minus 3 minus 5x minus 15 over x minus 3. Now remember, like I said, your next step is to always put either the left side all together of the equal sign and the right side all together, correct? So now I can write the left side's all together already, so I can just rewrite it. And the right side I can write all over x minus 3 because I have a common denominator. So I get 6x minus 5x minus 15 over x minus 3. As of right now, I made the common error. What's common error? Yeah. Right, I didn't apply that -1 in, right? I didn't subtract 5x minus 15. I just subtracted 5x. Okay, so when you have that subtraction sign, you have to remember to subtract everything behind it. So here I'm going to subtract 5x, and I'm going to subtract -15, which makes me actually add it, right? Now what can I do next? I can either collect like terms and then do this, or I can say, hey, I can now just set those numerators equal to each other, because if this denominator equals this denominator, then that numerator must equal that numerator. Before I cancel off denominators, what should I always do? State MPVs. And I'm going to go over here in this corner and I'm going to say x can't equal 0 and 3. Why do I put this at the very last spot of my question? So it reminds me to do what? Check for what, Joe? Using the non-permissible values, you're going to check for extraneous roots from the non-permissible values. All right, so we're going to have 18 equals 6x minus 5x plus 15. Put my x's together. 18 equals 6x minus 5x is x plus 15. Brittany, what am I going to do now? Yeah, minus 15 over. So I get x equals 3. And I'm happy, and I circle that on the multiple choice, and I get it wrong because what? It's extraneous. Over here, I said x can't equal 0 and 3, and here I said x equals 3. The extraneous root, it's an extraneous root because the NPV trumps it. It's out. No solution. There is no solution for this x value. So for D, I need to make myself a common denominator. What's common to 2, 4, and 3, McKinley? 2, 4, and 3. Yeah. So for 2, 4, and 3, it's going to be 12. So Paige, what do I multiply the first one by? So x over 2 times 6 times 6. What about the next one? Times 3. Oops. And the last one? 4. And when I do the top, I have to do the bottom. Because if you don't multiply the top and the bottom both by 4, you're changing the whole equation. When you multiply the top by 4 and the bottom by 4, that's 4 over 4, which is 1. If you multiply anything by 1, it doesn't change the equation, right? So that's why you have to do to the top and to the bottom. So I have 6x over 12 minus, and this 3 has to go into the whole thing. So minus 6x plus 15 over 12 equals 16 over 12. I don't have any NPVs or non-permissible values because there's no, in the next step. So I have no non-permissible values because there's no variables in the denominator. So then we can collect this side together. So we can go all over 12, and then we go 6x minus 6x. You're minusing the 6x and you're minusing the 15 equals 16 over 12. Now they're both over 12, so I can cancel them and just write the numerators equal. 6x minus 6x cancels, and I'm left with negative 15 equals 16. What does that mean? No solution. Because these don't. Okay. Now this one here, a plus 2, a squared minus 4, 2 minus a. What I'm going to do first is make my denominators try and possibly do GCFs or difference of squares and see if I can maybe make something in the denominators match, because right now that would be terrible to have to multiply by all of those different things. So this one is 2 over a plus 2. A squared plus 4, oh, that's minus, sorry. Minus a squared plus 4. And what's a squared minus 4, Alexis? Yes, so what would you get? A plus 2 and a minus 2, because it's the difference of squares. Now, just an aside, this 2 minus a, I always like writing them with the variable first, the number next. So this is actually negative a plus 2. All of the rest of them are positive a's. So remember I said if we have the same thing but wrong signs, what should we do? Take out a negative 1. So if I take a negative 1 out of negative a plus 2, if I pull a negative 1 out, I'm left with a minus 2. And now that's going to match one of these, right? So this is negative a plus 2. And if I pull negative 1 out, I get a minus 2. So on the bottom here, I'm going to write negative 1, a minus 2, and then a. Now what you could do is multiply all of them by negative 1, because you need negative 1 to get a common denominator between all of them. Or what can you do? Negative 1 is just literally a negative sign on the bottom, correct? So remember this from before. If I gave you this, don't have to write it, just pay attention. Say I gave you 3/4 like this, and I put the negative up here. That's timesing by negative 1, technically. I could technically write this as negative 1 times 3 over 4. It would be the same thing, correct? So I could say negative 3 over 4, or I could say negative 3 over 4, or I could say 3 over negative 4. This is the same, correct? We agree? So if I have a over negative 1, a minus 2, what could I do with that negative 1 instead? So it's not on the bottom, I don't have to make common denominators with it. Move it to the top, right? So I could put this up here, and then this goes away. And now I don't have to try and make negative 1 a common denominator with everything. Less work. So you can only do that with a negative 1. Now what's my common denominators? A plus 2 and a minus 2. So you try it out. See how you do. All right. So this left side, you have to multiply by a minus 2. And way over here, you're going to have to multiply by a plus 2. So we know our NPVs are a can't equal plus or minus 2. And we're going to have to check that at the end. Now, a times 2 is 2a. Negative 2 times 2 is minus 4 over a minus 2a plus 2. And then minus a squared plus 4 over a minus 2a plus 2 equals negative a squared minus 2a, a minus 2a plus 2. All right, so then we can write this whole side over a plus 2a minus 2. And we're going to get 2a minus 4 minus a squared minus 4, because you have to subtract the a squared and the 4, equals negative a squared minus 2a over a minus 2a plus 2. So now we actually have an a squared. If you guys get a variable that you don't like t or k or something like that, you switch them to x's. I don't care. Okay? Keep that in mind. So if you don't like a's and you do x's, that's fine with me. Now, we can write our numerators equal to each other. These ones happen to have a squareds, but the great thing about this particular question is the a squareds cancel. So you're not going to actually have a quadratic. You'll still have a linear like before. If we have a quadratic, though, we're going to have to use quadratic formula, which is on your formula sheet over here. You can see it. It's on the bottom left. It's down here. We're going to use that today as well. But they won't force you to factor very often. It would have to be, in order for them to force you to factor, it would have to be like James solved using these steps. Where did he make an oopsie? And you'd have to say step 1, step 2, step 3, step 4, and they'd have to factor in it. So most of the time, we're going to be using quadratic formula to solve. So if we have a quadratic, but we aren't going to have one here because our denominators are going to cancel, and we're going to be left with 2a minus 4 minus a squared minus 4 equals negative a squared minus 2a. And the first thing I'm going to do is move the a squareds over. So I'm going to move this a squared over. I'm going to add it. When I add a squared to a negative a squared, they actually cancel, and the squareds are gone. So it's not as ugly as it looks like it's going to be. So now we're left with 2a minus 4 is minus 8 equals negative 2a. Because my a squared is just crossed off. And now I want to get my a's together, so I'm going to subtract this 2a so it's over here. I'm going to get negative 8 equals negative 4a. Divided by negative 4. A equals 2. What's my problem? 8 can't equal 2, right? So no solution. So will it always give me no solution? That's craziness. I just picked a few that would get you no solution, but you aren't going to get no solution a lot. You might get 2 roots and one of them doesn't work. Sometimes you'll get it where one doesn't work, but for the most part, they'll give you an answer. Yeah. Okay, flip over. You try number 1 and number 2, please. A hint for number 1 that most people don't see is you can pull a 2 out of here. So this first part I have to multiply by 2 and x plus 1. This one I'm going to have to multiply by 2 and x. And this one I'm just going to have to multiply by x. So here I'm going to put the 2 and 2 together first and get 4x plus 1 over 2x plus 1 plus 2x over 2x plus 1 equals 7x over 2x plus 1. And x can't equal 0 or negative 1 based on our non-permissible values. If we combine this whole side, we're going to get 4x plus 4 plus 2x over 2x plus 1 equals 7x over 2x plus 1. And then these cancel, and I'm left with 4x plus 2x, which is 6x, plus 4 equals 7x. Subtract my 6x, and I get 4 equals x. So C. Two isn't bad because the common denominator is just going to be x plus 1, right? So I'm going to have times this side by x plus 1. And the 2 is just over a 1. So I get 3x over x plus 1 equals 2x plus 2 over x plus 1. And x can't equal negative 1. Denominators, so then I can write my numerators equal 3x equals 2x plus 2. Subtract my 2x to get my x's together, and x equals 2. Then I want you to flip to your textbook because we're going to do a question out of there. Write down this question, okay? So you want to solve this. Solve x plus 3 over x minus 1 equals 2x plus 1. Now this question looks like, okay, so this question looks like it's not too hard, right? I'll just multiply both sides by x minus 1. Well, this left side I don't have to, and the right side I will, and life will be good. Except for when I multiply the second side by x minus 1, I'm actually going to get an x squared that isn't going to cancel. So it actually is a little bit more difficult than it looks. So let's try it out and see. So up till now, if we did get an x squared, our x squared's canceled. And most of the time we didn't have an x squared, so we just solved for x and we were done, right? This time we're going to get an x squared that stays. So let's see what happens, because you get one of these on your test too. So times by x minus 1 times by x minus 1. And I'm going to get x plus 3 over x minus 1 equals, and then these are a foiling. So 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is positive 1x. 1 times negative 1 is negative 1, all over x minus 1. So now I have two denominators that are the same, so I can cross them off, but I'm stuck with an x squared, right? So what do I do? Same steps, that's all I did. So I cross off my x minus 1s, and I say x plus 3 equals 2x squared, and I can combine these. Negative 2x plus 1x is negative x minus 1. Now, if this was just normal solving from before, what you would do is you would just solve for x and go on. But we have an x squared, so you can't do that. So what I always say to do whenever you get an x squared, you have to remember to do this. Whenever you get an x squared, you want to get it into this form over here. Because look, it says you can use this quadratic equation. It even tells you this nicely on the diploma formula sheet, which you'll get one of these every single test. So it says here that in order to use this, I have to have this for ax squared plus bx plus c equals 0. So I can use the quadratic formula if my equation's in that form. So basically what it means is I need to have my equation equal to 0. So I like when my x squared is positive, so I'm going to move everything to it. So I'm going to subtract the x, and I'm going to subtract the 3. I'm going to subtract the x, I'm going to subtract the 3. So now I have 0 equals 2x squared minus 2x minus 4. And what the quadratic formula says is I have to have it in ax squared plus bx plus c equals 0. That's the format I have to have it in. So we can line that up. We can say, okay, it's ax squared plus bx plus c. B and c don't have to be positive, even though it has a positive sign in front of it. They don't have to be. And then it equals 0. So what's that telling me? That's telling me that a for the quadratic formula is going to be 2. So I'm going to put 2 in for every a in the quadratic formula. B is negative 2. C is negative 4. So for the quadratic formula, wherever I have an a, I'm going to put in 2. Wherever I have a b, I'm going to put in negative 2. And wherever c, I'm going to put in negative 4. And the quadratic formula you don't have to memorize. So if you say to me, do we get that formula or not? If it's on that formula sheet, you get it. If it's not on that formula sheet, you don't. That is the diploma formula sheet. So everything that's on there and in those exact orders is where you're going to find on the formula sheet. Okay? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, whether you were in 20-2 or 20-1, it does not matter. You did the quadratic formula. Okay? So for the b's, I'm going to plug in negative 2. For the c's, I'm going to plug in negative 4. And for the a's, I'm going to plug in 2. So what do we get? We're going to get x equals, now watch this. It's negative. The sign's negative, right? And then I fill in b. What's b? Negative 2. So what's this actually going to end up being? Positive, right? Because the formula has a negative and then a negative 2. Plus or minus, b squared is negative squared, negative 2 squared, minus 4 times a. A we said is 2, and c we said is negative 4. Because remember, whatever's in front of the x squared is always your a. Whatever's in front of the x is always your b. Whatever is a constant at the back without a variable is always your c. Always. You have to put in that order. And then all over, the whole thing is over 2a, 2 times 2. Now what happens is people will think just the square root sign's over it. No, the entire top is over the entire bottom. The entire numerator is over the entire denominator. You have to do this in a specific order. You can't punch it into your calculator all at once, you guys. First off, there's a plus or minus sign on the quadratic formula. There's no plus or minus button on your calculator. Okay? So what I'm going to do is simplify it. I'm going to go x equals negative 2 times negative 1 is 2, plus or minus, and then you can put this in your calculator, whatever under the square root all at once, but you need to put the negative 2 in brackets. You can't just go negative 2 squared and not have it in brackets. So everyone try it and see if you get the same answer. Punch it in your calculator. Bless you. So what you'd have to do is just put in this in your calculator like this. You can go negative 2 in brackets squared. If you don't put negative 2 in brackets and squared, it's going to tell you it's negative 4 and your answer will be wrong every time. Okay? So bracket negative 2 bracket squared minus 4 times 2 times negative 4. You don't have to put these brackets in if you don't want to. You can just go negative 4 times 2 times negative 4. And when you do that, you should get 36. If you didn't get 36, you're not typing it in right. So everyone should practice typing it in, because what happens if you just don't know how to put it in your calculator? That would suck. It would not be very good for your test. If you did all this work and then just put that in wrong, that would be sad. Now, we also want to test and see if this is a perfect square. The square root of 36, if you try it, is actually 6, which is nice when it works out. Sometimes it gives you a decimal and it isn't nice, but that's just how it is. Okay? So for this one, it does actually work out nice. I get x equals 2 plus or minus, 6, plus or minus 6, because when I go square root 36, I get 6, not root 6, I get 6 over 4. This gets me 2 answers, because there's a plus or minus sign that results in 2 answers. So at this point, I split it up into my 2 answers. I'm going to get 2 answers from this question. I'm going to get x equals 2 plus 6 divided by 4. And then I'm going to get x equals 2 minus 6 divided by 4. This one's 8 divided by 4, or 2. And this one is negative 4 divided by 4, or negative 1. And what's the last thing you have to check for? Non-permissible values, which were 1. X can't equal 1. Right? Because we had x minus 1. Are either of those 1? No. So our answers are x equals negative 1 and 2. Both of them work. I had you do number 1 last day on page 258. Today, I want you to do on page 258 number 3A, B, and D. You don't have to do C, because C is this question. Okay? And I don't know why I said 3. It's a 5. Number 5, A, B, D, sorry. And 6 all.